I'm Abhishek Pathak. I'm a program manager on the Azure networking team.
And I'm Matt Reed. I'm also a program manager in the Azure networking group.
And today we're going to talk about Azure Network Watcher, which is a network monitoring and diagnostic service that we recently GA'd. So before we started creating the service, we structured our thinking around 4 pillars. The first one was topology, which is basically know your network, the capability to visualize your network topology. And not only just limit it to visualizing, but also how can you overlay health and other systems. And that's our thinking on this pillar, and that's how we want to evolve it. The second one is, once you know what's happening in your system, you need the right set of diagnostic tools to actually go ahead and diagnose your issues that are there in the networking environment. For that, we've got network diagnostics as the second pillar, where we'll keep investing in all kinds of tools, and we'll show you a few of what we've created so far. Third thing is metrics. No monitoring and diagnostic system is complete without having a rich set of metric data available. So this particular pillar focuses on providing you with the right set of metric information. And similarly, you need logs. You need all kinds of diagnostic logs so that you can actually go ahead and investigate and understand what's happening, not only in your system, but also what can you do it proactively? How can you make your system better? How can you refine it? And that would be our goal going forward for the logs. So when we were creating these pillars, the main thing that we had in our mind when we were creating this service was to empower all our customers to monitor, diagnose, and gain insights into their network. And in order to do so, we said that the platform should have all the native capabilities, and we should provide it in terms of metrics, logs, diagnostic tooling, so that you can actually go ahead and investigate, troubleshoot, and measure the network performance and diagnose issues that are there. And not only that, we want to make sure that all the data that's being generated in these by our service can be consumed by all the Azure service and provide you more value-added features. So we wanted to make sure that there's a rich integration with the Azure services. And on the same lines, we want to make sure that the integration exists with a third-party ecosystem as well. So you might be using some tools which you are very familiar with. We want to make sure that those tools can also consume the data that's being created for you. And this also includes all the open source tools that exist right now. And we're working on all those integrations.
Now, Abhishek, you've talked a lot about how the service is structured. Why don't we jump into a demo and show what we've got?
Yeah, that'll be a good idea. So how about I show you what the service looks like? So before I go into the service, how about we take a look at what goes around in the system? How do you see the system right now? So I have a resource group over here called Contoso application, right? In which what I've done is I have got, if you look at it here, I have got a virtual network and this Contoso network. This virtual network has got 3 subnets in it, right? And each subnet, what I've done is I've created a VM in each of these subnets, and I've applied a network security group rule to each of the subnets again. Now, if this was a big deployment and you have hundreds of VMs in a subnet, it becomes really difficult for you to understand what's going on in the system. Okay.
Now, how would we visualize this?
So to visualize this, you can actually go ahead and let's take a look at how the Network Watcher interface looks like on the portal. So what we have over here is Network Watcher. And one of the things like we talked about as our pillars was viewing the topology. So you go and click on topology, and you click on the subscription over here. And Contoso application was our resource group. And what you see over here is the virtual networks. If you have more than one virtual network in your system, all of them will appear over here. So in this case, when I click it, I'm able to see how the network topology looks like. Now I see a Contoso network over here, and I have a front-end subnet, an NVA subnet, and a back-end subnet. So Matt, would you like to talk more about how this topology works and how is it done?
Yes, of course. So like Abhishek mentioned, we have 3 subnets here. And for each of these, we have an NSG applied to it to restrict traffic. So on the front-end subnet, we're only accepting traffic from the internet and then also from our network virtual appliance. And we've got a database in the back-end subnet that we're querying from our machines in the front-end subnet. And all of this is accomplished using user-defined routes that we can see here with our route table and our routing rule.
Nice. So what you're trying to say is that if I'm trying to RDP into my front-end subnet over here and going into dynamic 0, that won't be allowed?
No, that wouldn't be allowed. So you would have to use your virtual machine in your NVA subnet as a jump box to get into your machine in your front-end subnet.
Oh, okay. So Now, here's a normal scenario, right? I'm a developer and I find out that, okay, I need to go and look into this particular VM and identify, and I want to just RDP into the machine, and I'm unable to do so. And that would have happened to you a couple of times, right?
Yep.
So what we have done is we have provided you with some diagnostic tools. One of them is called IP Flow Verify. So what it does is that in this case, you can actually go ahead and check that, am I allowed to RDP into this particular VM or not, right? So I go and pick up my resource group. I choose my VM, the dynamic 0, and this is the NIC, and this is a TCP, and it's an inbound because I'm going to connect it over here. I provide the local port as 3389. Then I go into my remote IP.
And where are you connecting from here?
I'm connecting from my COPNET over here. So it's 10.38.12.14. And then I'll say the remote IP is any port over here. And I say check. Now what it is doing is it's going and validating whether I can RDP into the machine or not. And if there was a network security group that was actually blocking me. So with that, with one few click, I'm able to see that default inbound deny all is the one that's not allowing me to do so. But didn't you just say in topology that I can actually go ahead and go to my NVA and then RDP into it?
Yeah, we're using that as a jump box to get into your front-end machine.
So how about we check that then, right, if this works. So I look at it in the same way. Can I RDP into the jump box now? So the IPs have changed over here. And then I go check.
And is this doing a logical test of all of the rules?
Yes, it's a logical test. I mean, we're not sending any packets, but we are validating how the rules are applied. And then we do that logically. Yes, you're right. So now we see that allow RDP contoso CorpNet is the rule that will allow, and I can now successfully RDP into my jump box, like how you've configured, and actually go ahead over there.
Yeah. Now we talked about this routing. What if I need to, ensure the configuration of the routing that I've put in place?
Excellent. So for that, we have got another diagnostic tool, which is called Next Hop. So what it does is, once you pick up your particular resource group and a resource over here, you can identify what my next hop would be. So say, for example, I think in the application, the way it's been deployed, the front-end VM can talk to the back-end VM using just the appliance, right? That's how it goes. So let's take a look at, this is my dynamic 0, which is
the front-end VM.
And the destination over here is my back-end VM, which is 2.4.
Which is a separate subnet.
Separate subnet. And then let's take a look at next hop. And if you've configured it right, it should tell me that it's a virtual appliance that it's going to, right? Okay, let's take a look at it. Oh, yes. So this is the virtual appliance, and that's the IP, which is my dynamic 1. And it's the subnet over there.
Yeah, we've got the corresponding route table as well.
Oh, excellent.
Now, we've talked a little bit on testing just for a single VM and route, if a rule is allowed or what the route we have configured. What about if I want to get an overall understanding of how my NSGs are configured on a particular VM?
Yes, and that is something gets really complicated, right? When you have multiple rules, and then sometimes you apply NSG on a subnet, and sometimes on the NIC, it just becomes difficult what the effective rules are. For that, we have another diagnostic tool over here, which is called Group Security View. Now, in this case, let's pick up the same Contoso application over here, and let's go to Dynamic 0 in this case. And what we observe, what it'll do is it'll gather and identify what is my effective rule that's on that particular NIC. It'll give me all that information. So over here, what you see is you got your default rules, which are the platform rules that are always configured, which is default, allow VNet inbound, and other rules over here. And then these are the user rules that you've defined.
Now, are those applied on the subnet or on the NIC itself?
Good question. So let's take a look at what rules are applied on the subnet. As you see, these are all the rules that you saw, the custom rules are on the subnet. And when you go to a network interface, there are no rules that are applied over there, because in the configuration, the NSG was applied to the subnet and not the NIC. So you might have a different NSG applied to the NIC. In that case, it will show up over here.
Awesome.
Yeah.
We've shown all of these configuration tools that you can help diagnose your setup and how your VMs are and your network is configured. What if we want to see what's actually going on, from resources talking to other resources in our network? Can we do that?
Yeah, you made something like a flow tuple, if I can tell you what's happening in the communication going on.
Of course.
Well, exactly. And going on to our fourth pillar, which is diagnostic logs, what we have for you is network security group logs. So now if I were to go back into my Control Center application, what you see over here is these are the 3 network security groups, and I have enabled these logs. Now what these logs actually do is they have got your flow information recorded, and for each and every NIC that those flows are hitting. And not only that, we also tell you that what NSG is actually responsible for it and what rule. So it gives you a particular rule, it tells you what MAC address, and it also gives you the 5-tuple information like the epoch time when the flow was created, your source and destination IP and port. It tells you whether it was a TCP or a UDP protocol that was being initiated, inbound and outbound connection, and it also tells you whether it was allowed or denied. So
that's a lot of info. Why don't we show what these logs actually look like?
Exactly. So let's take a look. This is a log that gets recorded, and I have it over here for you. So it's a JSON format. So it starts with the record, and you have your timestamp over here, your system ID, category is your flow log event, you have your resource IDs over here, and then we get into the properties where we talk about each and individual flows. The way the flow is structured is you've got your rule, and then all the flows that are hitting that particular rule. In this case, we can see for a particular MAC address, here are the flow tuples. This is your epoch time, and then you have your source IP, your destination IP over here, your source port, destination port, whether it's a TCP or UDP, inbound, outbound, or whether it was allowed or denied. Now these flows get generated, updated. This particular blob gets updated every few minutes. And obviously based on, if you're getting flows on a particular NIC or not, or if it's hitting an NSG, it'll get updated, and these logs get rolled over every 1 hour. So for every 1 hour, you'll have a new JSON file that's created for you. So that's what it is. But sometimes you will wonder that if you have hundreds and hundreds of logs or thousands of flows that are coming, and it becomes really humanly difficult to actually go ahead and pass through all these things and extract meaningful information out of it. Mm-hmm. So Matt, why don't you show what you've got for that?
Yeah, we have a solution for that. So several solutions for that, actually. The first I'll start with is using Power BI to visualize these flow logs. So we published an article about how you can use Power BI, leverage Power BI to view your network security group flow logs. And what we've done is we provided you with a template. And so when you download this template, which we have right here, and I'll open this up.
So this is readily available for users to just download and start using out of the box?
Available today. So when this finished loading, this template loads, we see that all we have to do is provide the storage account that we have configured all of our logs to be sent to, and then a number of logs that we want to pull from the storage account. Yeah. And once we do that, Power BI downloads and parses all of your logs, and so you can visualize and see your logs. Now,
so that's all I need to provide?
That's all you need to provide, storage account name and the number of log files. You might have to provide an access key to your storage account.
All right, so that you can get the access.
So that you can have access to it.
Okay, that makes sense.
It's secure. But right now, I'll just show a sample of what this looks like when you've loaded all the logs into it. So I'll cancel this and open it up. So I've gone ahead and loaded about 440,000 flows from my flow logs into this dashboard, and we can see, if we start at the top left, who's talking on my network. So the top talkers, the most number of flows by, in this case, source IPs. We then get information about how our flows look over time, in this case very constant, and these are by the direction. So we see we have more inbound than outbound flows, and we also have it by decision as well. And then further segmenting the flows, we can see for each network interface who is having the most flows. So here we have 2 NICs with about the similar amount of flows, but they're the top used NICs on the network. And then if we go down to the bottom, we can see things like flows by destination port, and then also by the NSG we have configured. Now this is just the template we provide. You also have access to all the fields of the data, so all the fields that Abhishek talked about within the logs, and you can customize this Power BI template for any use that you might have in addition to this.
Well, that's really good. And what if I want to use some open source tools to do the same thing? Do you have any integration built for that?
Yeah, we do. So in addition to this Power BI template that we have, we've also work to publish articles about how we can leverage flow logs using open source tools. So I will go over to our second article right below it, where we, in this case, we use the elk stack to parse all of our flow logs. So this is Elastic Stack on top of using Logstash, and then Kibana as a visualization.
All right, and this provides you all the tools where you can download it and install and all the configurations needed.
So all the configuration to set up
a
simple Elk Stack deployment, we provide that. And then you get to the visualizations. In this case, we're using Kibana. So I've already got a Kibana workspace pulled up, and we see we have similar information that I showed in the Power BI dashboard, but this is leveraging Kibana and the Elk Stack. And you can go and segment your flows any way you please, and also search and use the tool like you would for your other logs.
That's pretty neat. Yeah, so along with that, one thing that we missed earlier was to tell you, we talked about getting the storage configured. So this is how you actually go enable it. You must be wondering, how do you go enable these things, right? Yeah. So this one is currently disabled. I go onto the flow log settings, and all I have to do is turn the status on and provide a storage location over here. And then I can specify what my retention period would be. So normally it's set to 0, which is infinite. So it just keeps it over there for you, and you can actually go ahead and select how long do you want to keep it for. Okay, we save it, and that's all you need to do to enable the logs. Right. Okay. But sometimes just the flow information is not sufficient, right? I mean, sometimes you really want to know, can I get the wire data itself? Can I get every single packet that's being transmitted in and out of my particular NIC?
Yeah, maybe you want to troubleshoot an application.
Maybe you want to troubleshoot an application, or you want to get more insights, or you want to run other heuristics on the traffic that's flowing. So for that, Network Watcher also provides you with packet captures. So now, over here on the portal itself, you can actually go ahead and initiate a capture. So let's take a look at how does it look like. So all you got to do is you can go to Add, and then you can select your particular VM. I have Dynamic 0 over here, and then I call the VM over here. I can name it, build.
And then where do we save these captures?
So these captures, we can actually save it either on your storage account if you wish to. Like in this case, I can pick up my same Contoso application. There's already have one, so it tells me, yes, you can have the same thing. And it says that ensure that the extension is installed on it, which you can basically go onto a VM and install the Network Watcher extension.
Similar to other extensions that you might install.
Exactly. And once you've done that, and then you can select a storage location, either this, or you can say, you know what, I also want to keep a copy on my file on the local disk itself. We let you do that as well. Along with that, what you can say is, how many maximum bytes per packet should I capture? If you're just interested in the headers, you say, I just want 60 bytes over here, and that's it. You can say maximum bytes per session if you want to restrict it, and you can say, okay, after 1 GB of data being written, just stop it. Or you can say, I want to have a time slot, right? How long do I want to run it for? Right now, it's a maximum that you can go as 5 hours, which is the default setting, by the way, and you can specify any time limits.
And is this for both Windows and Linux?
Oh, yes, it is. It supports both Windows and Linux. So,
awesome.
Yeah. The other thing is, what we've done is we've added filters for you as well. Now, because sometimes you're not really interested in all the traffic. You're debugging a particular problem, and you know where the source and the destination IPs are, and you just want to focus on that particular thing, right? So what you can do is you can add filters over here. Say, for example, in this case, I can say, here's my TCP, and you can provide your local IP, local port, remote IP, or remote port, and you can add that as a filter. And these filters can go on. I can just say, okay, add this guy over here. So it only captures TCP. Then I can say, okay, for UDP, I'm only interested in a particular IP. And then you can add that filter too.
Oh, neat.
And all you got to do is, once you've added all these filters, you just press OK, and you're done, and your captures would start. I already have a capture that was taken earlier. And so once it's done, you would see the storage location over here. And I go click on it.
And what? How do we save these captures?
Oh, it just saves automatically once you provide the storage location.
Oh, and the format?
The format is .cap. It's a PCAP format, so there'll be a .cap file. And this is what I'm downloading. And the moment I open it, since I've got Wireshark already installed on my machine, it just opens it up over there. So you can start using the tools that you've been using in your environment, and the data that we generate is all in sync with it.
Awesome.
So that helps you. But oftentimes it's, when you want to take a capture, but sometimes you just don't know when things are breaking or something's going wrong, or you all of a sudden you see that there is an anomaly in your traffic, and at that point you need to go ahead and take a capture. So
can I do that programmatically, or?
Yes. So since all these are REST-based APIs, and we also provide PowerShell, CLI, and SDK for all of this, what we have done is we have created an integration with our serverless compute, which is Azure Functions. And if you go over here to our documentation page, you would find other details which says use packet capture to do proactive network monitoring with alerts and Azure Function. So it'll give you in detail what you can do is on a particular VM, you can configure an alert, and in the alert, you can provide a webhook to the Azure Function. And what happens is when the alert gets fired, the webhook initiates and it starts the capture. So I have over here the alert that we have configured. So let's go to the alerts here. Yeah. Let's go back to the VM. I've configured one over here.
And so by leveraging this, I can respond proactively to an anomaly that might occur on the network and look into the packet capture data once I've run it.
Exactly. That is exactly what you can do right now. And this is the function that we have shown. And by the way, you can get all the code is already there. So it tells you in a very detailed way how you can go about doing it, and how do you create the templates, and ultimately the configuring, and you've got your encrypted credentials over here, and then how you can actually use the Azure Functions and all the code that's required over here to do so.
Awesome.
So that's what you can do. Now, going back to a few other things, when we were talking about the logs, we also talked about giving you one place where you can configure all your diagnostic logs, right? And that's what we have over here in the logs is, so when you go and click on diagnostic logs, we show you all your networking resources in one place so that you can get an understanding whether it's a particular thing is enabled or disabled or what have you. Now in this case, if I pick up my resource group over here, the same Contoso, I see that there are only 3 elements which have diagnostic logs, which are my NSGs, and then you can look at the status of whether it's enabled or not. Yeah.
Cool.
So this is what we have in Network Watcher, and there are a lot more things that we are adding as we go forward. And please stay in tune, and we would really appreciate if you go and try it out and give us your feedback. And there are other resources that you can go to, such as if you want to look at the regional availability, our service page, documentation, where you can go and read all about the documentation, how you want to use the PowerShell, CLI, and also how do you integrate with other systems, right? Both on Azure as well as the third-party tools.
If I want to give feedback, I go to that?
Yes. If you got to give feedback, you got to come over here, and that'll be really nice, and we'll be waiting for the feedback. Right now, it's free for the 4-month promotional period, which ends in August 17, 2017. So looking forward to you using it and waiting for your feedback. Thank you.